Next up, we're going to do something a little bit different. We're going to do uh, a normal quadratic factoring method, but the problem is we don't have a quadratic. We have a quartic, which means a fourth degree polynomial. So the idea is, can we write it in quadratic form? So can we substitute some value into this equation here, or this expression here, x to the fourth plus 12 x squared plus 32, and can we somehow change it so that it becomes a quadratic? So the way we do that is we say, hey, let u be x squared. So think about it. If u is x squared, how could I rewrite x to the fourth? Well, that's really x squared squared, right? But u is x squared. So I'd write this u squared plus 12 times u plus 32. And now that's just a normal quadratic I can factor, just like before. Product is 32, sum is 12, that's 8 and 4. So that's going to tell me it's u plus 4, u plus 8. But remember, u was x squared, so I substitute it back in here, and I get x squared plus 4, x squared plus 8. Now, neither of those are factorable, but that's the idea of the process we're doing when we say write it in quadratic form. One thing you have to keep track of is there might be something that you need to do with the coefficients. So in example 5, we're going to try to write these things in quadratic form if we can. And the whole idea is to take the variable that's there. Oh, I wrote this problem down wrong. This is actually supposed to be n to the 8. There we go. That's fixed now. And we have to try to rewrite it somehow so that it's in a quadratic form. So one thing that I always like to start with is take a look at the highest degree there, n to the 8. How can I rewrite this so it's something squared? Well, it would need to be n to the 4 squared, right? So that's a big first clue to it. The only other clue that might matter is if there's some sort of coefficient. So what I'm going to do is I'm going to take a look at the 150 and think, is there any number in there squared that would go into it evenly? So I'm looking at perfect square factors of 150. And remember, your perfect squares are like 1, 4, 9, 16, 25. Ooh, 25. That should go into 150. 25 goes into 150 uh, 4, 6 times, right? So 150 is really 6 times 25. Well, and 25 is a perfect square. That's really just 5 squared. So now now I know I got to have a coefficient of 5 in here. So I'm going to let u equal 5 n to the fourth. Now that's important to pick out now because that's going to change what my other parts are going to be. So the 150 times n to the 8 is going to change into 6 times 5 n to the fourth squared. Because 5 squared is 25 times 6 is 150. N to the fourth squared is n to the eighth. Now if 5n to the fourth is what I'm substituting it in, right? Let's factor a 5 out of the 40 and we get 8 times 5n to the fourth. Ooh, now it matches. So I'm going to let u equal that. So it's 6u squared plus 8u minus 15. And that is my quadratic form. And we're not going to try to factor this. We're just putting it in quadratic form if it's possible. All right. Now let's look at part B here. I got y to the 8. And it doesn't have a coefficient, so I just have to rewrite that as some power of y squared. And it would have to be y to the fourth squared. So now I take a look at my linear part. Ooh, there's a problem. I only have y cubed. I don't have a y to the fourth. I have to have a y to the fourth, otherwise I can't substitute something in. So here I would say cannot be put in quadratic form.